Good morning. Today we will be doing the chapter electricity. We all know the importance of electricity in our lives. Today we cannot even imagine a day without electricity. There are various things in which there is a use of electricity. Actually, it is the main part or the basic part of life to live. If I tell you to go live in some village or somewhere there is no electricity, or suppose in summers there is no electricity, or in winters there is no electricity, then in summers you won't be able to survive due to that heat, and in winters we need it for hot water and everything. What does this constitute of? The basic question is how electricity is produced and how it is managed in a society. So let's start with the chapter electricity. Before that, we need to know certain concepts which I'll start right here. See, there are two types of charges. Okay, one is positive and another is negative. Now, this positive charge is due to protons and negative charge is due to electrons. Got it? Now, whenever we'll talk about electricity, we are never concerned with protons. Is it clear? We'll talk only and only about electrons. Why? I'll tell you the answer. Suppose I take one body which has 5 electrons in it, and if I ask you whether it is positively charged or negatively charged body, certain person will say that it's negatively charged due to this presence of 5 electrons. Certain person will say it will be neutral because if a body has electron, it has protons also, and various answers will be there. But I cannot say about this body whether it is positively charged or negatively charged until I make another body here with 2 electrons. Am I clear? I'll give one more example. Suppose I draw a line like this. Now if I ask you whether this is a longer one or the shorter one line, long or short line, you cannot say anything about until I draw this line or this line. Now I can say that this line is smaller than this one and this one is larger than this one. That means there is a comparative study in it. But in same case, we can say that that body A, I'll name it A and B. The body A is negatively charged with respect to B and B is positively charged with respect to A. Or else, if I make another body here which has 10 electrons in it, now I can say that body C is positively charged with respect to A and B both. Or I can say that body A is positively charged with respect to C and body A is negatively charged with respect to B. And about C, I can say that body C is negatively charged with respect to both A and B. Is it clear? So this is how do we confirm about the electrons. Once again, I'll repeat that whenever we'll talk about electricity, we are least concerned with protons. It's only electrons which matters to us. Clear? So now I can say that this body is negatively charged and this is positively charged and this is again with respect to this negatively charged. Is it clear? Now, my next question. How does electricity is produced? Are these charges movable or what? Anything else? We'll talk about that right now. What does electricity consist of? Suppose I make body A here and body B here. Is it clear? Now it has, suppose 10 electrons and it has 100 electrons. What if I connect it with a conductor? This is a conductor. Many of you must be knowing what is conductor. The conductor is a substance which facilitates the flow of electrons. I'll write it for you. conductors substances which allow current to pass through it. Is it clear? And insulator is a substance which does not allow electrons to pass in. First of all, let's discuss why conductor is a conductor, or why everything is not a conductor, only metals are good conductors. So, suppose I'll explain it to you here. Look at here. Now, suppose the body, wait. Suppose this is a wire, okay, and it has free electrons moving here and there. Randomly. Is it clear? These are known as free electrons. These are known as free electrons. Now, the moment it is attached to with a cell, these electrons line up and they start moving in a single row. So, it is these free electrons which are responsible for conduction of electricity. That means, whenever a conductor which has free electrons on its surface, they are responsible for conduction of electricity. That means they conduct electricity from one point to another one. Okay. Now, if a question has been asked, why conductors conduct electricity, why metals are the good conductors of electricity, so we'll answer in such a way that metals conduct electricity due to presence of their free electrons on their surface. Is it clear? Let's come back to the point now. What if I connect this conductor between A and B? It has 100 electrons and it has 10 electrons. Clear? Now what will happen is the electrons will start moving from 100 to 10 electrons. Is it clear again? By what time they will, till when these electrons will continue to move? Many of the students say until all the 100 electrons move from this point to this point. But no, answer is not correct. The correct answer is the movement of electrons will be there till both of the bodies have equal number of electrons. That means if I transfer electrons, then it will be the total number of electrons in this body will be 100 plus 10 divided by 2, that is 55 electrons will be transferred from here to here. Is it clear? And whenever electrons move, they conduct electricity, or it is known as electric current. Kindly note down all this thing. I'll get back to just in 2 minutes. So, we saw that electrons will continue to from higher number to lower number until the number of electrons are same in two bodies. Is it clear? Now, this movement of electrons, which is known as current, they will flow like current. We know that water current, wave current, this that like that. No, whenever electrons flow, they constitute electric current. They constitute electric current. So I can write flowing electrons constitute electric current. Got it? Same principle or same thing is seen in case of electric cell. I'll explain you how. We all know that dry cell has structure something like this. Inside it there is a chamber It's a rough sketch. Okay. Now I can say that suppose electrons are lying in like this. Got it? Now I connect it with a wire like this. So that these electrons will move from higher number to lower number. Till when? Till these electrons are equal in number in both the chambers, outer one as well as inner one. The moment the electrons are same in both the chambers, the cell will dry up, or it's not a useful cell for us now. It has been spoiled. Now, in whatever circuit I'll put it, suppose I want to put it in watch, or I want to put in some electric circuits on different kind, like a toy or a transistor or anything which works with electricity or electric energy, that will start functioning. This is how a dry cell works. So now we can define what is electric current. Okay, now I'll explain it to you. What is electric current? Suppose there are two bodies, A and B. Got it? Now this has 10 electrons and this has 100 electrons. I allowed only 25 electrons to move from B to A in time 5 seconds. Got it? So the definition of electric current is electric current is defined as amount of charge flowing per unit time. I can write it here. It is denoted by, suppose I want to write electric current, it is charge upon time. It is denoted by I, and charge is denoted by Q and T by T. Is it clear? Now, what is total charge? It will be told by NE by T, where E is 1.6 into 10 is to power minus 19 coulomb with minus sign over here. It is the charge on 1 electron. It is charge on 1 electron. So, if I want to calculate the value of current in this case, how will I do that? We know that number of electrons transferred are 25 into 1.6 into 10 is to power minus 19 divided by 5. 5 5s are 25, that is 8.0 into 10 is to power minus 19 ampere. Is it clear? So we can define that amount of charge flowing per unit time is known as electric current. Got it? Now, the unit of electric current. What is SI unit of electric current? I'll write it for you. The SI unit is ampere, and one ampere is defined as amount, sorry, 1 ampere is that current when 1 coulomb of charge flows through conductor in 1 second. Got it? Now I can write it like this also. Ampere is equal to 1 coulomb upon 1 second. Is it clear? That means when 1 coulomb of charge flows through the conductor for time 1 second, then the current between current is said to be, current flowing is said to be 1 ampere. Got it? Now, what is the instrument which we use, which has been used for measuring the electric current? What is that? It is ammeter. I'll write it for you. Ammeter is a device which is used for measuring electric current. Is it clear? Now please note it down. With that, we'll start with one question now. I'll write it for you. Suppose I give you a question. Calculate the number of electrons which constitutes 1 ampere of current. So what will be the answer here? We need to write the formula first, NE by T. Got it? Now here I is 1 ampere, T is 1 second, and E is 1.6 into 10 raised to power minus 19 coulomb. Got it? Now by putting the values for, we need to find NE is equal to I into T divided by 1.6 into 10 raised to power minus 19. So the answer will be N is equal to 1 upon 1.6 into 10 raised to power minus 19. Okay, or I can say N is equal to 6.25 into 10 raised to power 18 electrons will constitute. Is it clear? We can write in such a way. Got it? Now let me start with another term called potential difference. Now the next term which we will be using is potential difference. Alright. May I know what is potential difference? What is the word meaning of word potential? Potential word means capability. We call it capability or its capacity. Got it? Potential word means this. I'll explain you with a day-to-day example today. Suppose there's a building which has a tank over it. Here we have underground water in it, and first we fill up this tank with the help of motor. Water is filled here, and from here we drop a pipeline to add a tap. Now this tap is helpful for us for basic utilities. We know it very well in kitchen, in toilets, in bathroom, and everywhere. We know it. What I want to know is, when water was already present here, why do we have to shift it upwards and to let it come down? I'll give you the answer. What we have done is, we have created a difference in its potential or a capability or a capacity, with the help of which we will be using it for doing our work. We can see it here in a very well manner. See what is happening. From here I find that it's going like this, water is going upstairs, and it from the tank it's coming again down. The energy which has been used stored here is mgh, that is potential energy. We all know this. Is it clear? But we cannot use this formula in case of electrons. Can you tell me the reason why? I'll tell you the reason. The basic thing is that electrons are almost massless. Electrons are almost massless. They don't have mass. The order of their mass is 9.1 into 10 raised to power minus 31 kg, and it is too less. Hence, since there is no mass is zero, we cannot use this formula. So potential difference for electricity is basically difference in number of electrons. See, how does it happen? Suppose there are two bodies lying like here. It is connected with conductor. It is A, it is B. If there were 100 electrons here and 1000 electrons here, the electrons would have transferred from B to A. If it was 100 here and 10 here, the electrons would have moved from A to B. And if there would have been 100 electrons here and 100 electrons here, that means there will be no transfer of electrons. So basically, potential difference for electricity is just difference in number of two bodies. You must have observed this. Like if you are wearing shoes for longer time in a day, excuse me, and now you touch with a body, or when you take out the shoes, you touch a door or metallic door, or if someone touches you, all of a sudden we start kind of shock. You know why this is happening? Because the shoes what we are wearing, it has a rubber sole. For whole day, the electrons come and accumulate in our body. And the moment they come into contact with earth or with another person, which is a conductor only, these electrons will flow either from our body to him, or if he has more, from his body to ours. So both of us will feel a shock, a little bit of shock. That is a current type of thing. Another example which can be seen is while in blankets. You must have seen in blankets when they are rubbed in night, everything is dark enough, we'll find that there are certain sparkles or kind of sparkling happening around it. It is all due to that transfer of charges. Is it clear? So let me start here. Let me define it. What is potential difference? If I want to define it properly, how will I define? Just look here. Suppose this one body is here and one body is here. It has got 5 electrons, it has got 10 electrons, and I managed to transfer only 1 electron from B to A. Only 1 electron. So this body will have 6 electrons here and 9 electrons here. I can say that 1 electron has moved from B to A, or I can say that 1 positive charge has moved from A to B. I repeat, I can say that one electron has moved from B to A, which has actually happened. But I can also say that one positive charge has moved from A to B. It's a hypothetical, it's a hypothesis, So it will have definitely, when one positive charge has gone there, this charge will reduce and this charge will increase. So how will we define it? It is defined as amount of work done in moving unit positive charge from one point to another. It's necessary to write this one point to another. You know why? One point, why? Because potential difference cannot be of only 1 point. Basically, it is a comparative studies between 2 points where one of the body will have more electron and one of them will be having less electron. So this is potential difference. How is it denoted? It is denoted by letter V. Is it clear? So if I move one electron from one body to another, then it is known as positive charge moving from one point to another. And this is how do we define it. The definition is only of 2 marks. Please note it down right now. So now you know what is potential difference. Please do not try to learn only definition. Try to understand what is the difference between potential difference and what is potential difference actually. So now we can say that whenever there is a difference in number of electrons, or I can say that it is basically a cause due to which electrons move from one point to another, is known as potential difference between those 2 points. Clear? There is another term called electrostatic potential. We'll talk about that now. What is electrostatic potential? Suppose I have a gun, an electron gun, and I shoot one electron which goes to point infinity. I shoot an electron from an electron gun which goes to the infinity point. So what is electrostatic potential? It is amount of work done in moving unit charge from infinity to that point. Is it clear? So till now we have learned about potential difference and electrostatic potential. Now we'll talk about unit of potential difference. What is unit of potential difference? The SI unit is volt. Again it is denoted by only V. Got it? So I say define 1 volt. So the answer will be define 1 volt. So we know that potential difference is work done upon charge. So for this I'll write volt For this it is joule per coulomb. So when 1 joule of work is done in moving 1 coulomb of charge, then potential difference between those 2 points is said to be 1 volt. I'll write it for you. When 1 joule of work is done in moving 1 coulomb of charge, then potential difference between those 2 points is said to be 1 volt. Is it clear? Now, what is the instrument which is used for measuring the potential difference in any of the circuit? So, the answer is voltmeter is used to measure potential difference in a circuit. Is it clear? Now we'll be learning about certain circuits and all the samples. Till that time, please note this down. Now we'll be doing some electric circuit and some symbols, how to do them questions and all. Now first of all, let me tell you certain symbols. We know that this is used for a cell. This is used for battery. This is used for bulb. Wire not join. This or this is rheostat or variable resistance. This is used for resistance. This is used for ammeter. This is voltmeter. Got it? So these are certain symbols which we use to make a certain circuit. Now I'll tell you how to draw a circuit with various things. The basic principle behind a circuit is that, suppose this is ammeter, this is a battery, this is a switch, This is a voltmeter. This is RH. Got it? Now, right now this is a open key. If I put a dot here, it becomes a closed key. Is it clear? Voltmeter is always connected in parallel with the circuit. I'll be explaining to you about what is parallel in coming classes. But till now, just remember that it is connected in parallel like this. Ammeter is always connected in series. Ammeter is always connected in series. What is the reason behind it? It is connected in series because the ammeter has minimum resistance and the maximum current should pass through it. If a current passing through it, is a minimum resistance, hence it will burn out if it is connected in parallel. So minimum current should pass through it. Hence it is always connected in series. What about voltmeter? Voltmeter is connected in parallel because the maximum current should pass through it. Is it clear? Now, this is something what we call closed key, and this is, if I make it like this is a open key. Whenever we want to show the direction of electric current, it has to be always in a very different way. Like, we know that electrons always move from negative body to a positively charged body because the current flows or electrons flow from high potential to low potential. Hence, it's only electrons which move from one point to another. But whenever we talk about electric current in circuits, we always take it from positive to negative. Look here, I'll tell you how. The conventional direction of current is always taken positive to negative. That is opposite to flow of electrons. The specific reason behind is not known yet, but they say that by the time current was discovered by Benjamin Franklin, electrons were not discovered. Is it clear? Another theory says that whenever it's a work done in case of potential difference, the potential difference is never taken in negative. Hence, if we say that the conventional direction is always opposite to flow of electrons. If I make a box like this, so electrons will flow from negative to positive, but direction of current is always taken from positive to negative. Got it? Now, let's do one question regarding the circuit. Draw a circuit diagram consisting of a bulb and a 4 ohm resistance, ammeter and voltmeter across a resistance. Further, battery of 10 volts provided cell is of 2 volt each. Whenever we make these kind of diagram, first of all, let's make a bulb and a resistance wire, a ammeter, a key, and now since it is saying that we are provided with 2 volt each and we need 10 volt in total, so we'll be making 5 cells. Students, please remember that whenever we talk about number of specific cells, the positive and negative terminal should be equal. The terminal bigger one is showing positive terminal, the terminal smaller one is showing the negative terminal. Now, he's saying that we need to put the voltmeter across here. Is it clear? And we'll just put it off. Now we know that the direction of current will be like this, from positive to negative. Another thing to be noted down is that always remember positive of the battery should be connected to the positive of ammeter, and now from here it's negative of voltmeter to positive voltmeter. Just try to remember this point, that this positive is always connected with the positive terminal of this. So I hope I was clear till here. In next class, we will be doing Ohm's law, the resistance and different combinations. But till that time, please learn all this thing. God bless you all.